In this video we are going to learn about nth roots, or what we call them radicals. We are familiar with the square roots from before, so we know that square root of 25 equals 5, because 5 to the second power equals 25. That's why square root of 25 is 5, because we're looking for a number times itself is going to give us 25. We know square root of 81 is 9, same reason, because 9 times 9 is 81. So actually the square root is the opposite or inverse operation of the squaring. Like I have a number, if I square it I get 25. If I square root of 25 I get that number back, the 5. 9 I square it I get 81. I square root the 81 I get back the 9. So that's why we call it, or we say that the square root is the inverse operation of squaring. But we can apply that square root to higher exponent, like 3 to the 4th power. We know it's 81. So we can say that the 4th root of 81 is 3. We know 2 to the 5th power is 32. So we can say that the 5th root of 32 is 2. So in general, if a to the power n equals b, then the nth root of b is a, or a is the nth root of b. So when we look at this symbol here, 5th root of 32, the 5 is the index. This symbol, the square root symbol, we call it radical. Whatever inside the radical, we call it radicand. So 5th root of 32 is 2, because 2 power 5 is 32. Now, some real numbers has more than one root. Like for example, 25 has 2 square roots, 5 and negative 5, because 5 times 5 is 25, and negative 5 times negative 5 is also 25. The positive 5, we call it the principal square root. So positive square root of 25 equals 5, that's the principal square root. The negative one, we call it the negative square root. So negative square root of 25 equals negative 5, that's the negative square root. Positive or negative square root of 25 equals positive or negative 5. That's indicate both square roots of 25. Now we have an important thing to remember. If n is even, if this index is even, like for example you want to find square root of negative number or 4th root of negative number, as long as this n is negative, as long as this n is even and the number inside the radical is negative, there is going to be no real answer, because there is no number times itself is going to give us negative number. So when this index is even and over here the radicand is negative, there is no real answer. But if this n, this index is odd and the inside the radicand is negative, now we have negative answer. For example, if I want to find 5th root of negative 32, I'm looking for a number times itself 5 times to get negative 32. Yes, we have a negative answer, negative 2. If you multiply negative 2 times negative 2 5 times, you're going to get negative 32. But if you want to find 4th root of negative 16, index is even, radicand is negative, there is no real answer. There is no number you multiply times itself 4 times and the answer is negative. So keep that in mind, that's very important. Now there is another important concept. We can think about radicals as exponent like that. We know that a power half, if you raise a power half all to the second power, we have one base and two exponent. We keep the base, we multiply the exponents. So when you multiply a power 1/2 times another a power 1/2, it's same like a power half times 2 or a power 1. So as you can see that there is a number times itself is going to give you a. That number is a power 1/2. So a power 1/2 is the square root of a. So square root of a equals a power 1/2. So that's how we can connect square root and the exponent. So we can rewrite radicals as exponent. Same thing if I want to find third root of a. We know that a power 1/3 all power 3, that's going to give you a, because when you multiply the exponents you're going to get power 1. This means that third root of a could be written as a power 1/3. So in general, if I have nth root of a, we can write it as a power 1 over n. That's important, guys. We are going to use these in the examples. Just keep it in mind for now. What about if we have nth root of a power m? So the radical here is a power. So actually we can apply the same rule. Whatever inside, you're going to raise it to power 1 over the index. So a power m, power 1 over n. Now you need to multiply the two powers, the two exponents. So a power m, I can write it as m power over 1, then multiply it times 1 over n. When it's one base to exponents, we multiply the two exponents. When we multiply fractions, you just multiply straight across. M times 1 is m, 1 times n is n, so the answer is a power m over n. So the nth root of a power m is a power m over n. That's important. And this is important. Let me show you an example how we apply this. Square root x power 8. When it's square root, the index is invisible too. So now we're going to apply this rule. M over n, 8 over 2. X power 8 over 2, x power 4. Another example. Fifth root of z power 15. Apply the same thing. I can write it as exponent z power 15 over 5, z power 3. Now there is a very important concept. We need to know it for now. We are going to use it later in some problems. When you find an even root, when this is even, an even root of an even power, this is also even. So this is even and this is even. And the result, the answer, is going to be odd power. You must use the absolute value of the result to ensure that the answer is non-negative. What that mean? Look at this example. I want to find fourth root of negative 2 power 12. So now it's even root of even power. So when you divide negative 2, then you divide 12 and 4, 12 divided by 4, you get negative 2 to the third power. Now the answer negative 2 to the third power, now the answer or the result has a power which is odd. Now if you think about this, negative 2 power 3, that's going to be negative 8. Now remember, when this is even, you can't find even root of negative number. So actually this number is not negative, because negative 2 power 12, when you multiply negative 2 times negative 2 times negative 2 12 times, that's going to turn into a positive. So we're finding even root of positive number. But now over here, the way we did it, the answer is negative. That's why we mentioned over here, when the answer of when that's even root and even power, and the answer is a power of odd exponent here, you have to use absolute value. So the absolute value is going to turn the negative 8 into positive 8. So when you find an even root of an even power and the result is odd power, like this example, you have to use the absolute value. of the result, which is going to be 8. If I'm doing square root, even root of y power 10, so even root, even power, and the result is going to be y power 10 divided by 2, which is 5. So even root of even power and the result is odd power, you have to use absolute value, because this y could be negative. So if alright, let me show you some more examples, but before we do that, there is one important property we are going to use on these examples. That property, we call it product property of radicals. That property says that if we have the nth radical or the nth root of a times b, that's equal to the nth root of a by itself times the nth root of b. So over here we have a radical of product, and over here we have product of the radical. So we can separate them and find each radical by itself and then multiply them. An example, root 2 times root 8. That's already separated, like this side of the rule. And we don't know what's square root of 2 by itself, what's square root of 8 by itself. But we notice if we multiply 2 times 8, that's going to give us 16. And square root of 2 times 8, which is square root of 16, we know the answer is 4. So if you multiply them, we get perfect square, we get the answer. Another example, cubic root of 3 times cubic root of 9. Same thing, we don't know the answer of each one by itself. But if we multiply them, applying the product rule, is going to be cubic root of 3 times 9, or cubic root of 27, which is 3, because 3 times 3 times 3 is 27. Now remember, the name is product property, so you can only apply it and separate them only if they are multiplied, or you can combine them like this if we are multiplied. But if this is plus in between, you can separate them. If it's minus, you can separate them. Here the examples you want to do: simplify square root of 32x power 8. So we're going to copy the problem. Then we're going to apply the product rule, because it's 32 times x power 8. So we can separate them, square root of 32 by itself times square root of x power 8 by itself. 32, we're going to factor it, because we don't know what square root of 32, but we know 32 is divisible by 2. 2 is prime, so 2 times 16 is 32. 16 is perfect square, we know the square root of 16. So we are going to separate them to square root of 2 times square root of 16 by applying the product property of radicals. Times, over here to find the square root of x power 8, you just divide the power by the index. So it's going to be x power 8 divided by 2. Square root of 2, we don't know it. Square root of 16 is 4. X power 8 divided by 2, which is 4. Now, we know that multiplication is commutative, so we can rearrange them, makes no difference. So we are going to start with the 4 and then the x power 4, and then we are going to put the square root or the radical 2 at last. Another problem, you want to find the cubic root of x power 14. So over here, there is no product inside, it's only one term, so we divide the power, which is 14, by 3, but 14 is not divisible by 3. So what we are going to do, we are going to try to separate the x power 14 like into two groups. What is the highest number goes into 14 and divisible by 3? It's 12. So we're going to keep 12 x's together, because remember, x power 14 means x times x times x times x, 14 of them. So we're going to keep 12 of them together, because we can divide 12 by 3. And the other two, the remainder two, we're going to keep them together as x power 2. And then we are going to apply the product property. We're going to separate them. Cubic root of x power 12 times cubic root of x power 2. Over here, we're just going to divide x power 12 divided by 3. It's going to be x power 4 times cubic root of x power 2. Since this is less than the index, so we are done. Another example, we want to find 4th root of 16, a power 24, b power 13. Remember, we said before, if the index is even and the power is even, and you do the division, if the result is odd, we need to use absolute value for the A. Over here for the B, it's even index, but the power is odd, so we don't have to worry about that absolute value for the B. Now we're going to apply the product property because we have three things multiplied, the 16 and the A power 24 and the B power 13, so we can separate them. 4th root of 16 times 4th root of A power 24 times 4th root of B power 13. 16, what the 4th root of 16? What number times itself? 4 times give you 16, it's 2. If you don't know it, you just factor this. 2 is prime times 8. 8 is not prime, so the 8 you factor it again. It's going to be 2 times 4, and then you factor the 4 again. 2 times 2. So you can see it's 2 times 2 times 2 times 2. So what number times itself? 4 times gives 16, it's 2. 4th root of 8 power 24, just divide the power by the index. So it's going to be A power 6. Over here we know this from where we got the 2, so we can erase it now. A power 24 divided by 4, A power 6. B power 13, 13 divided by 4, 13 is not divisible by 4, so we're going to use the same trick we used before. We're going to keep what is the highest number goes into 13 divisible by 4, it's 12, so we're going to keep 12 together, B power 12, and there is one more left, we're going to keep it by itself. Then we apply the product rule over here, so bring down the 2, bring down the A power 6, apply the product rule. It's going to be 4th root of B power 12 times 4th root of B power 1. Even though that's even, you don't have to worry about if the division is going to give you odd answer to use absolute value, because originally it was even odd for the B, so we are not going to use absolute value for the B. Bring down the 2, bring down the A power 6, B power 12, what is the 4th root? Divide 12 by 4, the answer is 3, so that's going to be power 12 divided by 4, which is 3, multiplied by 4th root of B, and we are done. Here is one more example. Square root of 12, C power 6, D power 3. We can apply the product property because these are multiplied, so it's going to be square root of 12 times square root of C power 6 times square root of D power 3. Square root of 12, 12 is 4 times 3, so we can separate that into square root of 4, which is 2, times square root of 3, which we don't know it. Over here we have even index, the invisible 2, even power, so if the result is going to be odd power, you need to use absolute value. So when we divide 6 by 2, we get 3. Now we have to use absolute value. Over here it's even, but that's odd. So for the D, we are not going to use absolute value. D power 3 is not divisible by 2, so we are going to use the same trick we used before. What is the highest number goes into 3 and divisible by 2? It's 2, so we are going to separate them, D power 2 and D power 1. Square root of D power 2, that's going to be regular D. Square root of D, we don't know it, we're going to leave it square root of D. We're going to bring down the 2, the root 3, the absolute value. Now we are going to use the commutative property to just arrange these. So we are going to have the 2 at the beginning, then we are going to bring this 2 next, then the C power 3 absolute value, then the root 3 and the root D. These two square roots, we can apply the product property and we can combine them inside one radical. So it's going to be square root of 3 times D or 3D. And we are done. I'm going to show you a couple more examples. Over here we want to simplify cubic root of 27 y power 12 z power 7. Since this index is odd, you don't have to worry about the absolute value for this problem. Then we are going to apply the product property, so we are going to separate them. It's going to be cubic root of 27 times cubic root of y power 12 times cubic root of z power 7. 27, we know it's 3 times 3 times 3. So cubic root of 27 is 3. Since this has a power, we just divide 12 by 3. So it's going to be y power 4. Over here we need to divide 7 by 3, but 7 is not divisible by 3. We are going to use the same trick we used before. What is the highest number goes into 7 and divisible by 3? It's 6. So we're going to keep 6 of these 7 z's together, and whatever left, which is one more z by itself, then we apply the product rule over here to separate these. Bring down the 3, the y power 4. That's going to be separated. It's going to be cubic root of z power 6. Let me write it here. 3 y power 4 cubic root z power 6 times square root of z. So it's going to be 3 y power 4. Over here we just divide the power, the 4 by 3. So it's going to be z power 2 cubic root of z. Here is one more example. We are going to approach that example differently a little bit, especially if the numbers here you multiply is going to be a big number. So let's see how we're going to do that. Here we want to find 5 cubic roots. So actually this is odd. So when this is odd index, you don't have to worry about using absolute value for a or b. Same thing over here. So now we're going to apply the product property. So we're going to do the 5 times the 3 times the cubic root negative 12. When this is odd, this could be negative. No problem. Final answer is going to be negative. So negative 12a b power 4 multiplied by 18 a squared b power 7 equals 5 times 3, that's going to give you 15 cubic root negative. Instead of multiplying the 12 times the 18 and get big number and then figure what that cubic root is going to be, what we can do factorization. We try to write this as base and power. So for example 12, we factor the 12. So here is 12. If I factor to the 12 is going to be 2 times 6 to its prime. I'm trying to factor it to prime factors. 6 could be factored one more time because 6 is not prime. 2 is prime times 3 is prime. So actually it's 2 power 2 times 3. So it's 2 power 2 times 3. Then over here I have this a multiply times this a squared. That's going to be a cubed. B power 4 and the b power 7, that's going to be b power 11 because we add the exponent 4 plus 7 times 18. We're going to do the same thing for the 18. We're going to factor the 18. So here's the 18. 2 is prime times 9. 9 is not prime. 3 times 3. So the 18 is 2 power 1 times 3 power 2. So that's times 2 power 1 times 3 power 2. That's going to be equals to 15 cubic root negative. Now I have 2 power 2 over here and I have 2 power 1 over here. So that's going to be 2 power 3. We're going to add the exponents. Then we have 3 power 1 over here and we have 3 power 2 over here. When we multiply them, that's going to be 3 power 3. Then a power 3 b power 11 equals 15 cubic root negative 2 power 3 times cubic root 3 power 3 times cubic root a power 3 times cubic root b power 11. So that's equals 15. Cubic root of negative number, that's going to be negative, so times negative, then divide the power by the index. 3 divided by 3 is 1, so that's negative 2. Over here, same thing, is going to be 3 power 1 or 3. A power 3 divided by 3, a power 1. Time 11 is not divisible by 3. What's the highest number goes into 11 and divisible by 3? 9. So I'm going to rewrite it as cubic root of b power 9 multiplied by square root b power 2. Now 15 times negative 2, that's going to be negative 30. Negative 30 times 3, that's going to be negative 90. Multiplied by a multiplied by b power 3. 9 divided by 3 is 3. Square root of, not square root, I'm sorry, that should be cubic root. Cubic root b squared. And that's it.